So we're trying to figure out what is the limit of the y value, or the f of x value, as x gets closer and closer to 6. So as x gets closer to 6, y gets closer and closer to 4. So our best guess for the limit of f of x as x approaches 6 would be 4. We're going to use epsilon. Epsilon is always symmetrical. And what epsilon is, it's like it gives you the range that you can be within for y. So since epsilon here is 0.7, we'd go 0.7 above 4 and 0.7 below 4. Now we're going to find out where this function intersects these two lines. So there's one intersection here and there's another intersection here. So then I'm going to go and draw lines down from there. Okay, so as you can see, I drew lines down from the intersection points, so this would be one and this would be other. And when I looked at it, it came down that one of the lines came to 5.2 and the other one came to 6.5. So now to find delta, we have to find the difference between these distances. So the difference between 6 and 5.2 is 0.8, and the difference between 6 and 6.5 is 0.5. So that means that our delta value is equal to the smaller of the two, so it's 0.5. To solve for delta numerically, we would just plug in the y value plus or minus the epsilon value into f of x and solve for x, which would be our delta in this case. So for number 15, we would plug in 3.3 into f of x and 4.7 into f of x. After finding x numerically, I found that it was really close to what I thought it was graphically, and it's a nice way to check your answer to make sure you're right. To calculate algebraically a positive value of delta for any epsilon greater than 0, no matter how small, for this problem, you would just do some simple algebra to get delta by itself,